Hello. In this video, we're going to take a look at a complete vector problem where we put all of this together and see what we can figure out. Let's take a look at our example here. First off, notice we have a box that's acted on by three forces. We've got three different vectors here. Let's call that A, B, and C. And we've got a mass here of a box, and we are looking for an acceleration. Great. Let's sketch this out really simply first. Here's my box. Great. I have three forces, 30 newtons due north on this one. So I've got A is going that direction, 50 newtons west, 60 degrees towards north. So I'm going to go west and then 60 degrees towards north. So this one is going to be somewhere like that. That's going to be B. And then 70 newtons east, 30 degrees south. So east and then 30 towards south is about there. And that's going to be C. So right away, looking at this box here and just sort of figuring it out, I should end up with a vector that's somewhere like that. My resultant should be something north and east. We can actually figure out the exact details with our question, but that's sort of a sanity check to make sure that, yeah, this is about right. So right away, I'm going to take this, and in order to solve this, I need to break all three vectors down into components. So I need to decompose all three of my vectors here. These are three forces, so let's do the first one, which is going to be A here. This is 30 newtons north. North. Because this is one of the cardinal directions, I don't have an angle here, but I can directly convert this to component notation because I have 0 for my x component. It is not going east or west at all. So 0, 30. So there is my first vector. My second vector, I have 50 newtons west, 60 degrees towards north. Okay, figuring this out, I am going west and north, so I know that my x component is going to be negative and my y component is going to be positive. So let's break this down right away. My x component is going to be 50 cos 60. And I'm going to spill over here a little bit into the notes because I'm going to need the space. And 50 cos 60 is negative 25. That works out like that. I added the negative in here because I know that I'm going west here. So I'm going to add that in, added the negative because of the west. Okay, so I've got 25 newtons for my x component, and my y component is 50 sine 60, which works out to 43.30. It's positive because of the north here. So my components for B are 25, negative 25, and 43.30, like that. Great. My C vector here is 70 newtons east, 30 degrees south. So x is going to be 70 cos 30, and y is going to be 70 sine 30. Figuring those out, I have 60.62 for x and 35 for y. I have south here. This is going south, so this is negative y. There's my component notation for all three vectors. Okay, in order to combine all of these three, I need to use my component addition skills. So I'm doing A plus B plus C. So A plus B plus C, like this, just adding them all together. And I'm going to have 0 and 30 plus negative 25 and 43.30 Notice I'm using 2 decimal places. Plus 60.62 negative 35. Great. Working all 3 of those out, we end up with 35.62, positive 35.62, and 38.30. Both of these end up being positive, which makes sense because if we look up at our assumption here, we're assuming we're going to be going north and east, which means both these should be positive. Okay, here is the component addition or component notation of my resultant vector. So this is the resultant. The resultant is an answer to a vector problem. So there's my result, but the trick is I need to turn this back into a magnitude and direction because I need to get this out as a vector in magnitude and direction format in order to use it to find the acceleration. So this is a triangle here. I'm going to make a nice line so we can figure this out. My magnitude, like we did before, I'm going to use Pythagoras to figure this out. So I'm going to do 35.62 squared plus 38.30 squared, and take the square root of that. And that works out to 52.30 newtons. Okay, my direction, I'm going to do over on this side. In order to figure that out, I'm taking my inverse tan of my y, 38.30, over my x, 35.62. Notice it's y over x. And this here works out to 47.08 degrees. Okay. This here, both of these are positive, so I can actually write this as east 47.08 degrees, north, because they are both positive. So here's my magnitude, here's my direction. However, just because this is a long question, and vector questions where you have to take them all apart and put them all back together tend to be fairly long, I'm actually asking for an acceleration. This magnitude here is a force. So I'm going to take this force and use it in Newton's second law, F equals ma. Great. My force here, I've got 52.30 newtons. Equals, my mass is 100 kilograms. And that's multiplied by my acceleration. So doing the algebra here, this is going to work out to my acceleration is going to be 0.52 meters per second squared. Okay. There we go. 0.52 meters per second squared is my final answer for my acceleration. Great. This is not 100% complete yet because I do have my direction. Mass does not have a direction, so mass cannot affect the direction of this. So really straightforward, my final answer is 0.52 meters per second squared in the direction east 47.08 degrees north. So there we go. We've got our magnitude and our direction of our acceleration for our final answer. How do you solve one of these questions? Well, decompose, add them together, recompose, use your other formulas. So basically, you do all your vectors to turn all of your, in this case, all of your forces into one single force, and then you can move on to your other formulas. If you're trying to do this individually, it's not going to work very well. And usually with forces, if you have a bunch of them, you do the vector math to combine them to one force, and then you can move on to there. I hope this has been a little bit helpful. These problems tend to be fairly lengthy problems, but it's merely just a lot of trigonometry. So it's just making sure you know your trig from grade 10 pretty solid. I'm going to leave you with a little quick joke. What did Beethoven do after he died? He decomposed. Hope you've had a great day, and I'll see you in the next video.